Hey, welcome back. So now we will start learning about the object-oriented programming or OOP in Python. Okay, so what exactly is OOP? OOP stands for object-oriented programming. Okay, Python is an object-oriented language allowing you to structure your code using classes and objects for better organization and reusability. So whenever we are printing something with the type function, we have encountered the class keyword. Now we will discuss what exactly the classes and objects in Python and how we can create our own as well. Okay. So what are the advantages of object-oriented programming? Okay. So object-oriented programming provides a clear structure to our programs. Okay. OOP makes our code easier to maintain, reuse, and debug. And it helps keep your code dry. Basically, do not repeat yourself. Okay? And it allows you to build reusable application with less amount of code. All right? So this is basically the advantages of object-oriented programming. Okay? Now, what are the classes and objects in Python? So the concept of classes and objects is not confined to the Python programming language. Most of the programming language supports the object-oriented programming, and there the concept of the classes and objects are quite similar. Okay? So classes and objects are two core concepts in object-oriented programming. A class defines what an object should look like, and an object is created based on that particular class. Okay? So for example, we have been talking about the fruit altogether, like the examples of fruits. Okay? So a class can be a fruit. Okay? And the object can be apple, banana, and mango, like different type of fruits. Okay? So all of the fruits here has a common thing, like they grow on trees, right? So that thing can be inside of the fruit class, and depending on which tree, we can get apple, banana, and mango. Okay. Then once again, the example of a class is a car, and the objects from the car can be Volvo, Audi, Toyota, and so on and so forth. The main structure of a car is same, but different brands offer different functionalities. So this is the same concept here inside of the programming as well. So we will define a class, and depending on the input, we will create different sort of output objects with that same class. Okay? So when you create an object from a class, it inherits all the variables and functions defined inside that class. Okay, so for example, this car has a function called start. So all of the cars which is created from this car class, okay, all of them will have the start function inside of them. Okay, once again, the fruit grows on tree, so all of the fruits will inherit that particular thing. Like, hey, the fruits will grow on tree. So apple will grow on a tree, banana and mango will grow on a tree as well. Okay, so I hope that makes sense. So basically, classes are the blueprints for the objects. Okay, so here Python classes and objects. So now let's discuss the Python implementation. Python is an object-oriented programming language. Almost everything in Python is an object with its properties and methods. A class is like an object constructor or a blueprint for creating objects. Okay, so let's see that in action. First of all, we have been working with this one, right? So let's do numbers 1, 2, 3. Okay, and the numbers is a list, right? So I can do print type of numbers. Okay, this is a totally valid thing to do. Now run the program. We are getting the class of list. So what exactly we are doing currently right now? So this is a special syntax for the list basically. So whenever we are doing something like this, so we are opening the square brackets and putting some sort of a data inside of that, the list is now instantiated with that particular data inside of Python. Okay. And one of the other things which I can show it to you is the help function. So here I will comment out this one and do something like print help, and inside of that I can pass the class for which we want the help, so list. Okay, so here right now if I run the program, as you can see, here is our help. So help on class list module built-ins. So this is the class of list which is taking the object. So list is here. Then we are having this sort of methods which starts with double underscore and ends with double underscore. These are called the dunder or the magic methods. Okay, so we usually do not access these methods. These methods are for only internal usage of the class. So we have many of the things here, right? And then if I just scroll down a little bit, after our these methods, the dunder methods, we are having this one, append. Okay, then we are having the clear method, the copy method, which we have seen inside of this course, right? Count, extend, index, insert, pop, remove, reverse, sort, and so on. Okay, and each of the methods has their own thing here. Okay, and then we have basically that. Okay, so if you want to check for other classes, for example integers or floats or something like that, you can use the help function so that you can see what exactly inside of that particular class. Okay, to quit from this terminal window, you can just press Q. All right. Okay, so as you can see, all of the things whatever we have been using so far is an object in Python. Okay, so now let's see how we can create our own class inside of Python. Okay, so I will just get rid of this one, and here how we can create our own class. So to do that, we have to use the class keyword. So class, and then we will write the name of our class. I can do something like person, something like that. This is totally valid, but while using the classes and naming the classes, we use the Pascal case. That is the convention. What exactly is the Pascal case? It starts with the capital letter and the consecutive words will have the capital letters as well. So if I just do something like my class, it is good, but the C should be capital. So this is a Pascal case name. Okay, so let's go with my class here. And here what I can do, after this colon, this is currently empty, right? And if I just now run the program, it will give us an error like, hey, indentation error. So what we can do, we have seen the pass keyword before, so pass. So now we are saying like, hey, I will put something inside of this particular class in a moment. Okay, and then what we can do, we can do something like this. So how we can use this particular class? So to use this particular class, we have to create an object. So I can do obj1 equals to, we have to call our class. So my class and parenthesis. Okay, this is very, very important. And after this video, basically in the next video, we will see how we can get some data inside of a class as well. All right. And now what I can do print object1 as well. So if I just do that, run the program, we are getting this one. So my class object at this location. So without this my class, let's do something like this. Person. That is a little bit more better. So write this one, and as you can see, we are running this program and we are getting this one. Okay. Now let's see what exactly is the type of object 1. Okay. If I do that, now run the program, we are getting class main person. Okay. So we are defining our own type inside of Python as well. Okay. This is not an inbuilt type, right? We have been working with the primitive data types for quite long time, and this is not a primitive data type. This type is created by us. All right. So here, what we can do something like this. We can add a variable as well. So something like name equals to John. Okay. Something like that. And here we can access the name as well by simply object1 dot name. Okay, as you can see, VS Code is auto completing for us as well. Run the program, we are getting John. Okay, so we have seen how to create an object here. Now how we can delete the object? We can delete the object by using the del. So del obj1, and now if I run the program, we are getting an error like, hey, obj1 is not defined. Now here we can create multiple objects from the same class as well. So I can do something like this. So object1, let's do something like this. Okay, person1 equals to person. Okay, let's do something like this. So person1, person2, person3, person4, and person5. Not person5. Okay, and here if I just do something like this, so let's do person1. Okay, and dot, we can access the name as well. So person1. Okay, so here as you can see, depending on this person class, we have created 5 different objects. And here one thing we have to remember, each object is independent and has its own copy of the class property. Currently right now we are having this variable which is name, which is basically hard coded here. But in the future we will see how we can create the dynamic objects as well. So each and every object is independent. Okay, the person1 is not dependent on the person2, and person2 is not dependent on the person3, and so on and so forth. Okay, all right. So this is how we can create classes in Python, and we can create object, basically instantiate a class and create an object in Python. Okay, awesome. Hey, welcome back. In this video, we will discuss about the double underscore init double underscore method in Python classes. So what exactly is this method and why it is very, very important? So the double underscore init double underscore, or the dunder init method, is a very special method for Python classes. All classes have a built-in method called double underscore init double underscore, which is always executed when the class is being initiated. This is very, very important. Okay. The double underscore init double underscore method is used to assign values to object properties or to perform operations that are necessary when the object is being created. Okay. So let's see that in action. First of all, as you can see, we are having this simple class which we have created in the last video. So class person, name equals to John. Okay, this is quite simple. We can declare some variable inside of the class itself inside of Python. Now, if I do something like this, so person1 equals to person. All right. and we will do person2 as well is person. Okay, and now we can print the person1 dot name, and once again we can do the same with the person2. Okay, all right. So this is our simple class, and we are just instantiating the class with this one, and currently right now we are accessing the name for each of the person. So person1 dot name, person2 dot name. Now if I just run the program, we are getting John and John for the both of the print statement, which is not good. This name is not dynamic. So how we can make the name dynamic for each and every person? Name should be dynamic, right? So to do that, what we have to do, we have to use the init method. Okay, so now we will define the init method. Def double underscore init double underscore, and inside of the parameters here we have to pass the self first, self. Okay, so this self keyword is very important. By using the self keyword, the class knows what exactly is that particular object which is basically being called. Okay, so here what we can do something like this. So self dot name equals to John. Okay, so what exactly we are saying right now? We are saying whenever this particular person class is instantiated and created an object, that particular object should have the name property, and that name is currently not dynamic, it is static, which is John. Okay, so let's see that in action. Run the program. We are getting once again John and John. Okay, now how we can make this name dynamic? To make this name dynamic, what we have to do, we have to pass our own parameter. Here we can call it name or something like first name or something like that. I will call that name. Okay, and here what I'll do, I will do something like this, equals to name. So what exactly I am saying here? So whenever we are instantiating the person class, the user will provide a name, which is this one, and that particular name should be attached to the object with this particular attribute, which is currently name. It can be something like first name as well, something like that. We can do anything, but the convention is to call it exactly what exactly we are passing it here. So self dot name. Okay, all right. So what exactly we are saying once again, whenever this person class will be instantiated, this person class should provide a name, which is here, and that name should be attached to the object with this special attribute called name. Okay, now when we are instantiating this person, we have to provide the name. So here John. Okay, and here we can do Jane. And here one thing to point out, we are not providing anything for the self. So basically Python internally sees this argument and it will pass that particular argument to the second one. Basically it will not pass it to the self. Okay, so we are getting the name here. The self is a special parameter which we will discuss in the next video in detail. Okay, all right. So until now we have been doing something like this. So person, whenever the person class is instantiated, we are getting the name, and that name should be attached to that particular object with the name attribute here. Okay, all right. Now if I run the program, we are getting John for the person 1 and we are getting Jane for the person 2. Okay, awesome. So in that way we have made our person class dynamic, and here we can take multiple things as well. So name, we can do age as well. Okay, and here we can do something like self dot age equals to age once again. And now if I just run the program, we will get some errors here. Okay, so this is very similar to the normal function call. We are not directly calling this init method here, like we are not calling that inside of the code, but it is being called internally, right? So to fulfill the number of arguments here, we have to pass the age as well. So let's do something like 20, and Jane should be something like, let's do 24. Okay, and here what we can do after this one, person1 dot age, and here person2 dot age. Okay, all right. Now if I just run the program, we are getting John 20, Jane 24. Okay, I hope that makes sense. So in that way, the init method is quite useful, right? So whenever we want to attach some sort of a dynamic data to our instantiated object, then we use the init method, and most of the time we use the init method for our classes, right? We use the classes for accessing dynamic data. Okay, so this person class is a blueprint, and as you can see, this person1 is an object, person2 is an object as well, depending on the blueprint. That blueprint has different data, right? But it has a proper structure. Okay, awesome. So the init method is called automatically every time the class is being used to create a new object. So for the person1, we are calling the init method. For the person2, we are calling the init method as well. Okay. So now why we want to use the init method? As you can see, init method is basically used for setting up the dynamic data. And without the init method, you would need to set properties manually for each object. And that defeats the purpose of the object-oriented programming altogether, right? So we use the init method for dynamic data. Using the init method makes it easier to create objects with initial values. Okay, all right. And here, as you can see, this function works like a regular function. We can add the default values as well. If I do something like 0 here, okay, we can do that. So if I do something like this, or let's do 18, okay, something like that. And now if I do not pass anything for John, the age for John should be 18. Okay, John 18, Jane 24. We are not getting any sort of errors. Okay, let's do something like 20. And here for John, let's do 22. Okay, if I just do that, now, as you can see, John is 22 years old, Jane is 24 years old. Okay, all right. And here, as you can see, we can get multiple parameters with the init method, and we can get as much parameters as we want. Okay, we can get age, we can get city, and so on and so forth. It is not limited by the parameter numbers. Okay, so you can create as much complex object as you need. Okay, awesome. So this is the init method, or the _init _ method for classes in Python. Hey, welcome back. In this video, we will discuss about the self parameter and the instance method of a class in Python. So we have seen the self parameter here, okay? And when we are instantiating the class, we do not have to pass anything for the self, okay? So the self is managed by Python, and the self refers to the instantiated object. Okay, all right. So what exactly is the self parameter? The self parameter is a reference to the current instance of the class. Okay, it is used to access properties and methods that belong to the class. Okay, so here, as you can see, we have to use the self so that we can set the name and the age for each and every object. Okay, so here let's discuss about some of the instance method. So what exactly is an instance method? It is quite simple. So basically the instance method is a function which lives inside of the class. Okay, so we have the special init function here, but here we can create our own functions as well. So let's create a simple function. So def create, and here, as well, we have to pass the self as the first parameter, self. Okay, and then if we want to take any sort of other parameters, something like thing or something like that, we can do that here. Okay, but currently right now we will not be accessing any sort of other parameters here. Okay, and here what we can do something like this. So return something like an f string, hi there, and comma, and then we can do self dot name. Okay, quite simple. So here what exactly is happening, we are accessing the instance of the class, basically the object which is being created for the class, and that particular object we are accessing the self.name. Okay, so here if I just do something like this, so what I'll do, I will comment out these ones, and here I will print, or I will just get rid of this ones. Okay, I don't want that. Print person1 dot greet, and we have to call the function as well. Okay, it is just like when we are having this sort of a list one or something like that, and dot, we have the pop method and we have to call it here, right? We are doing exactly the same sort of a thing. Okay, so here we are doing something like this, and once again we can do the person2 dot greet as well. Okay, now if I run the program, we are getting hi there John and hi there Jane. Okay, so this is how we can use the self parameter for our instance methods as well. You have to remember the first parameter should be the self parameter for the instance method. Basically any method inside of the class, it should have the first parameter, which is the self. Okay, all right. So here you should remember the self parameter must be the first parameter of any method inside of a class. Okay, all right. So now why we want to use the self? Okay, so without the self, Python would not know which object's property you want to access. Okay, so basically without this self, Python don't know if you want to access the name of the first object or the second object. Okay, so in that way the self is very useful, right? The self parameter represents the created object. Okay, all right. Now one thing I want to point out here, the self parameter does not have to be named self. Okay, I can do something like this object. Okay, as you can see, this is quite good. If I just do that and here run the program, once again our code does not break. But with that being said, this is a common practice, and if you are working with a code base, the first parameter of these methods of inside of the class is called self. So I will do self. Okay, all right. So here I have written down this one. Self does not have to be named self. Okay, it does not have to be named self. You can call it whatever you like, but it has to be the first parameter of any method in the class. Okay, while you can use a different name, it is strongly recommended to use the self, as it is the convention in Python and makes your code more readable to the others. Okay, all right. So now let's discuss more about the instance methods. So let's add another method which takes some sort of an input as well. So def, let's do likes, and it will take self for the first one. Okay, and for the second one it will take the thing. Okay, and here it can return the f string. So self dot name likes the thing. Okay, all right. So here what we can do something like this. So print person1 dot likes, And here we have to pass a thing. As you can see, VS Code is suggesting here as well. This is one of the other benefits of object-oriented programming, that we have a very good amount of auto-completions inside of any good code editor. Okay, so here we will pass something like ice cream. Okay, and for person 2, it can be something like, let's do candy. Okay, all right. So now here it should print out the things like, hey, this first person name likes thing. Okay, so run the program. We are getting, hi there John, hi there Jane. John likes ice cream, Jane likes candy. Okay, so awesome. So this is how we can create the instance method, which can take some different parameters with them. Okay, and one thing once again to point out here is that we do not put anything for the self. Okay, we are passing the thing here. Okay, this one, this parameter here, and Python internally checks, okay, we are passing something, so that should be the second one, the second parameter for this function. Okay, the first one is reserved for self. All right, so now let's see another instance method here. Okay, so def, let's do welcome, and that will take the self. Okay, and here what we want to first greet the user, and then we want to print some of the other things here. So what I can do something like this. So let's do message equals to, and then self.greet. Okay, all right. So in that way we can access the instance method inside of another instance method. Okay, and here I can print the message, comma, and then we can do something like welcome. Okay, to our app. Okay, something like that. So here if I just do something like this, so print. Okay, so we do not have to print because the welcome method here has the print statement. So let's do person1 dot welcome, and let's do person2 dot welcome. Okay, all right. So now if I run the program, we are getting, hi there John, welcome to our app. Hi there Jane, welcome to our app. Okay, I hope that makes sense. So here in this way we can access one instance method inside of another instance method by using the self parameter. Okay, awesome. I hope that makes sense. And in this video we have learned about the self parameter for instance methods in Python. Hey, welcome back. In this video we will discuss about the class attributes or the class properties in Python. So what exactly are the class properties? Properties are variables that belong to a class. They store data for each object created from the class. Okay, so here we have two different type of properties. So we have the class properties and we have the object properties. Okay, and what exactly is the difference between them? The properties defined inside of the init method belongs to each object, and these are called the instance properties. Okay, or instance attributes, something like this one, self.name. Okay, so this is the example of the instance property. Okay, all right. And then properties defined outside methods belong to the class itself. Okay, and these are called the class properties and are shared by all objects. Okay, all right. So this is basically the definition of the class property. Currently right now inside of our person class, we do not have any sort of a class property or the class attribute yet. We will create that in this video. So as you can see, I am working with this person class which we have created in the last videos. Okay, all right, and we are creating person 1 and person 2. Okay, so now all of the person which are being created by this person class should be human, right? So in that case, we can define a class property which is species, and that can be human. Okay, so here what we can do something like this: species equals to human. All right, as you can see, I am not defining species inside of the init method. Okay, I am defining the species outside of the init method, and I am not using the self also. Okay, the self keyword here will be available inside of the init method. We are not doing something like self.species. We are just saying species, and which is human. Okay, so this is the example of the class property, okay, or the class attribute. Now how we can access this one, this species? So all of the objects which is being created by this person class will have this species attached to them. So here we are creating person 1 and person 2. Here what we can do something like this: print, and here person 1 dot species, and also person 2 dot species as well. Okay, all right, now if I run the program, we are getting human here. Okay, but this is not how we usually access the class attributes. Okay, so this is good, we can do that, but it is not how we usually access the class attributes. To access the class attributes, we call the basically this particular thing the property with the class itself. So what do I mean by that? So here, if we want to access the species of the person, what we can do something like this. So print, then here we can call the class itself. So person dot species. Okay, now run the program, we are getting human. So as you can see, we are getting human here, okay, as the species. So this is how we access the class properties. Okay, now for example, what we want to keep track of all of the users or all of the persons that has been created by this person class. So how we can do that? We can do that by the class attributes here. So here we can do something like this: person created equals to, it will be starting from 0, and whenever we are creating the person, this init method will be called, and here we can update the person created. So how we can update that? We can update that by using the class itself here. So person dot, and then as you can see, we are having the person created, so plus equals to 1. Okay, so now what I can do, I can just get rid of this print statement here. I can print here person dot person created. I will copy this line and paste it down here. Okay, now run the program, we are getting 0 and 2. Okay, so as you can see, in this way, by using this syntax, basically the class name and then the attribute with the dot, we can modify the class attributes here. Okay, so this is basically the class attributes. Also, what we can do, we can add a last name for our users as well, for our person, and we can add that here. Okay, so this is how we can create and modify the class attributes in Python. Okay, so in this video, what we have done, just recap. So we have been talking about the class attributes or the class properties. So we have seen two types of properties. One of them is the class property and another one is the object property. The object property is something like this, which we basically instantiate in the init method, and the class properties are these ones which we instantiate outside of the all of the methods. Basically, if I just do something like this, so count equals to something like 0, so what exactly will happen? This count variable will be scoped to this greet function, right? This is not a global variable and this is not a variable which we can access by using the class. Okay, so this is not a class attribute. All right, here is the example of the class attribute. Okay, so we have discussed about the class and the object properties, and here we have discussed about the instance properties and the class properties here as well. Okay, awesome. So these are the class attributes in Python. Hey, welcome back. In this video, we will discuss about the class methods in Python. Okay, in Python, a class method is a method that is bound directly to the class rather than its individual object instances. Okay, currently, as you can see, we are having this greet method, the likes method, and the welcome method. These are basically attached to the object instances. Okay, these are not the class methods. Okay, so here we will create our own class method and then see what exactly is the difference. Okay, so for example, here I want to have a method which returns like, hey, how many person has been created by our person class. Okay, so how we can do that? We can do that quite simply. First of all, I will get just below the init here. Okay, and here, first of all, what exactly we have to do? We have to define a function, def get underscore, let's do created person. Okay, and here we will have our class method. But as you can see, if I just create this sort of a function here, that will be attached to the object instance. Okay, to differentiate that, Python has a decorator, which is the at class method decorator. So at class method. Okay, and I know we have not talked about the decorators in Python, but we will surely do in the upcoming videos. Okay, now once we apply this decorator, then this particular method or this function will be a class method. Okay, and instead of self, it will have the class itself, so CLS. Okay, and here I can print the CLS for now. Okay, so as you can see, this is our very simple class method. Okay, so here we are adding this class method decorator, and after that we are having this particular function which will get the class itself. Okay, I can call it self as well, so self, that is totally valid, but to be more specific and to follow the conventions, we should call it CLS. Okay, all right, now how we can call this method? Okay, so let's see that. To call this method, what we have to do? We have to do something like this. So after this person has been created, so what I'll do, I'll just get rid of this one, get rid of this one, get rid of this one as well. Okay, and here we can do something like person dot get created person. Okay, all right, or get created person number. Okay, person number. All right, that should be updated as well. Okay, so now if I run the program, we are getting, as you can see, the person class itself. We are not getting an object back. Okay, we are getting the class itself. All right, I hope that you are able to understand what is the difference between the instance method and the class method. Okay, now what I can do something like this: return the if string. There are something like So we have to have the person created. Okay, so person dot person created, person created. Okay, quite simple. All right. Now, if I just call this function here, and as you can see, it is now returning the f string. So that is why we have to print. And here we go. Okay. Now, if I run the program, as you can see, there are 2 person created. Okay. So quite simple enough. And as you can see, this particular method is attached to this person class itself. Okay. I hope that makes sense. All right, so this is the class method in general. So this is a quite simple method, and you might be wondering why we want to use something like that. So whenever we are getting some sort of a abstract data, we use the class method. And whenever we want to create some sort of a method which is attached to the class itself, we use the class method there. Okay, so now for practice, let's create another class method, which will be a little bit more complicated. Okay. So first of all, what I can do something like this, add class method. Okay. And here we will create the function from underscore birth underscore year. So what exactly is the thinking behind this function? So currently right now, what we have to do, we have to pass the name and the age, right? And by default, the age is 20. But for example, we want to create the user by their birth year. So how we can do that? We have to do some calculations, right? For that. So we will create this class method for creating that particular object. Okay. So first of all, this class method will have the class. Then it should get the name, and then it should get the year. Okay. Now we have to calculate the age equals to something like that. Okay. I will just go with 10 for right now. And here what we can do, we can return the class with these ones. So we will pass the name and the age. Okay. Simple enough. So what exactly we are doing? We are doing something like this. So the name which we will be getting, that will be here inside of the name, and we will get the age here. So how we can calculate the age? We can calculate the age by using the datetime module. Okay. So on the top of our file, we can import, or let's do from datetime import date. Okay. And here what we can do inside of this class method, instead of this hard-coded 10, we can do something like this: date dot today dot year minus the year which we are passing. So currently we are in 2026. Okay. And that will minus the year of birth for that particular user, and we will get the age from that. Okay. Simple enough. All right. So now we can create another person here. So what we can do something like this: person 3. So we can do something like this, which is good, or we can do something like this. So person dot from birth year, and we have to pass the name, which can be something like Sarah, and the birth year might be something like 2000. Okay. I hope that makes sense. So now we can do something like this, and here we will get the get created person number. So the person number should be 3 here. Run the program. As you can see, there are 3 persons created. So our function worked properly. Okay. And also I can do something like this. So let's print the person 3, and let's see that object. Run the program. We are getting this object here. So to do that, what we can do dot and then double underscore dict double underscore. So it will be represented as a dictionary. Run the program. As you can see, we are getting the name, which is Sarah, and age, which is 26. Okay, so I hope that makes sense. So this is how we can create our own class methods for our classes, okay, in Python. All right, so in this video we have learned about the class methods in Python. Hey, welcome back. In this video we will discuss about the double underscore wrapper double underscore method in Python. Okay, so in Python, the double underscore wrapper double underscore is a special magic method that is used to return an unambiguous string representation of an object. It is primarily designed for developers, debugging, and logging purposes. Okay, so in case if you are following the last video, here we have been doing something like this. Okay, so we wanted to see the person 3. Okay, to see the person 3, we have to do something like this, double underscore dict double underscore. If I just do that, then we are getting this dictionary representation of that object. But without this one, the object will be a little bit different, right? So we are getting something like this, main person object at some memory location. This is not that much great, right? So what if we can change this particular representation of the object? We can change that by using the double underscore wrapper double underscore method here. Okay, so first of all, we will get back here. Okay, at the last def double underscore pair double underscore, this is the method which will get the self. Okay, and here what we can do, we can return a string. Okay, the f string here, and here what we can do, we can do something like this, self dot name is self dot age years old. Okay, if I just do that, then what will happen? So if I just run the program right now, then we will see a different result. As you can see, we are getting Sarah is 26 years old. Okay, so this is basically overriding the default object representation string inside of Python objects. Okay, so this is quite better, right? So in that way, whenever we are printing the object itself, then we will be getting something like this, Sarah is 26 years old. Okay, so in that way we can use the wrapper method to represent our objects in a little bit more nicer way. Okay, awesome. So this is the wrapper method, and also one thing to point out here, it should return a string. Okay, all right, so this is the wrapper method in Python. Hey, welcome back. In this video we will discuss about inheritance in Python object oriented programming. So we have been talking about the classes and the objects throughout the videos, right? And we have created multiple classes. Now, what if you are creating two classes, let's say, and the two classes has the common properties and methods, and just one of the method is different in both of the classes. So how you can reduce the duplication of the code? To reduce the duplication of the code, you can use inheritance. Okay, so inheritance allows us to define a class that inherits all the methods and properties from another class. Okay, the parent class is the class being inherited from, also called the base class. The child class is the class that inherits from another class, also called the derived class. Okay, so how we can create a child class? So to create a class that inherits the functionality from another class, send the parent class as a parameter when creating the child class. Okay, so let's see that in action. First of all, let's create a class of person. So class person. Okay, here we can do the init method basically the constructor method in it. All right, it will take self and it will take the first name and last name. All right, and here we can do self dot first name equals to first name, self dot last name equals to last name. Okay, and here we can write a basic method as well. So def print name, or let's do something like full name. Okay, full name, that will be taking the self just, and here it will return the f string of, let's do self dot first name and a space and then self dot last name. Okay, and here we can do something like the full name is, and something like that. Okay, let's add a colon. So this is our simple class. Okay, now what we can do something like this. So let's do p1 for person 1 equals to something like person. Let's add the first name, which is John. Let's add the last name, which is Doe. Okay, and here we can print the p1 basically. All right, now if I just run the program, we are getting this object. But now what we can do something like, so now what we can do p1 dot full name, and we have to call the method. All right, so this is the method which is returning us this f string here. Run the program, we are getting the full name is John Doe. This is totally fine. Now let's create a child class here as well. Okay, so I will get rid of this one. So this is our person class. Okay, now let's create a class of student. So class student. Okay, and here I will just add pass. So now what I want, this student should be a person, right? And the person should have the first name, last name, and so on, right? And that should inherit all of these, like these things, the first name, last name, and also the full name method. So how we can do that? We can do that by using the inheritance. So what we have to do, we have to open up the parenthesis. Okay, and here we have to pass the parent class, which is the base class, which is person. Okay, all right. Now what will happen, this student class will have the first name, last name, and the full name method here as well. Okay, so here what we can do something like this. So s1 equals to a student. So here, as you can see inside of the VS Code, we are getting these suggestions. So we have to pass the first name and the last name. So let's add once again John as the first name and add a comma. As you can see, we have to pass the last name as well. So Doe. Okay, and here we can do something like print s1 dot, as you can see, we are getting once again auto completions as well. So full name. Okay, we have to call that. All right, so what we have done here, so we have defined the base class, which is the person class. The person class has the first name and the last name, and here, as you can see, we are getting the full name method here as well. And after that, we have defined another class, which is the student class, and all of the student should be the person, right? And that is why it is inheriting from the person class. Okay, so how to inherit? So basically we have to open up the parenthesis and pass the basically the parent class here inside of that. And now all of the things, these properties or the attributes like the first name, last name, and also the methods which we are defining inside of the base class are available inside of the student class. Okay. Now if I run the program, as you can see, we are instantiating this student class with the S1. Okay. So now if I run the program, we are getting the full name is John Doe. Okay. So this is basically how the inheritance work. Okay. And this is a really simple example of inheritance in action. Okay. So what we can do, we can add the init method as well inside of this student class here. Okay. So the init function is called automatically every time the class is being used to create an object. Okay. So here what we can do something like this. Instead of pass, we can do def double underscore init double underscore, and here what we have to do, we have to pass the self, and once again it should need the first name, so first underscore name, and last name, last underscore name. Okay. And here what we have to do, something like this, self dot first name equals to first name, self dot last name equals to last name. Okay. So now as you can see, we are having two different init methods here. Okay. One in the person and another one inside of the student. So now let's run the program and let's see what happens. So as you can see, the full name is John Doe. Okay. So everything works properly. All right. But the thing is, this is code duplication, right? So this init method and this init method is totally exactly the same. So how we can reduce it? So we can reduce it in some different ways. So first, I will show you a way to reduce this code, and then we can improve upon that particular code. So now to reduce this particular code from duplication inside of these both classes, what we can do, we can get rid of this one. So I will get rid of these two lines here. And here inside of this init method of the student class, okay, here what we can do something like this, person, and then dot double underscore init double underscore, and here we can pass the self, then first name and last name. Okay. So now as you can see, we are not duplicating our code anymore. Okay. So if I now run the program, once again, the full name is John Doe. Okay. So we have now successfully added the init function here. Okay. And kept the inheritance from the parent class as well. Okay. And we are calling the parent class, and here we are calling the init method from the parent class here. Okay. But can we do better? Yes, we can do better. So here what we are doing, we are calling the init method of the base class. Okay. And this particular thing, this particular syntax, I do not recommend you to do. Instead, Python has another quite nice syntax, which is the super function. Okay. So Python also has the super function that will make the child class inherit all the methods and properties from its parent. Okay. So instead of this one, I will just comment out this one. What we can do something like this. Okay, I will just get rid of this one. So we can call the super function, and here we can do double underscore init, and here we do not have to pass the self. Okay, we have to pass the first name and the last name, as you can see from here inside of the VS Code. So first name and last name. Okay. All right. Now, as you can see, our code is much more clean, right? And now if I run the program, once again, we are getting the full name is John Doe. Okay. Awesome. So this is how we can use the super function which Python provides. So by using the super function, you do not have to use the name of the parent element. Okay, basically the parent class. It will automatically inherit the methods and properties from its parent. Okay. All right. Now, as you can see, our student class is looking good. But Right now, student should be a little bit more different than the person, right? Student can have the graduation year. Okay, so how we can add different properties? Okay, it is quite simple. So here what we can do something like this. So after we are calling the super, we can do self dot, let's do graduation year equals to, let's do 2026. Okay, so we can do that. And now after we are doing something like this, what we can do something like this. So let's go here and let's do graduation year. Okay, now if I run the program, we are getting 2026 and the full name is John Doe. Okay, so this is quite simple. Okay, so in this example, what exactly we are doing, we are attaching another property inside of the self, basically that particular object here. Okay, and the value is 2026. Now how we can get dynamic values while creating the student object? It is quite simple as well. So here inside of the init method, after the first name and last name, we can get the year as well. Okay, so I can do something like this. So graduation, or let's do year. Okay, all right, and here what we can do something like this. So year. Okay, so the year is not hard coded anymore. So now what we have to do while creating this particular student, what we have to do here, we have to pass the year as well. So what exactly the year? Let's pass 2024, let's say. Okay, and now run the program. We are getting 2024 once again. Okay, so in that way we can get the dynamic values and attached it to the object properties. Okay, all right. Now what we can do, we can add different methods as well. So currently right now the person class has this full name method, but the student class has no method. Okay, so it will inherit the full name method, which it does. But if we want to create another method, what we can do, just go below the init method basically and create another method. So something like greet. Okay, and here we have to pass the self. Okay, all right, and then what we can do something like this, return, and do something like the if string, like welcome. Okay, welcome. Then let's do something like self dot first name, and then let's do something like self dot last name here. Okay, to the class of, and then we can do self dot graduation year. Okay, as you can see, this is quite simple. Now what we can do, we can go here, so print and do s1 dot, and we can do something like greet. Okay, we can call the greet function here. All right, now if I just run the program, we are getting welcome John Doe to the class of 2024. Okay, we are missing a period. All right, so run the program once again. So hey, welcome John Doe to the class of 2024. So in that way we can create and add different methods to our basically child class here. Okay, so yeah, this is basically it. So this is the inheritance in Python. Okay, so whenever we are having code duplication in our classes in Python, we can use inheritance so that we can just basically create a common class which will hold the common like attributes and the methods, and then we can extend the class, basically that base class, to another class which is the child class with all of the properties and the like functionalities with their own properties and with their own functionalities as well. So yeah, this is inheritance in Python. Okay, hey, welcome back. In this video we will discuss about the multiple inheritance in Python. So what exactly is multiple inheritance? In the last video, we have discussed about the inheritance in detail in Python classes. So multiple inheritance in Python is a feature that allows a child class to inherit attributes and methods from more than one parent class. Okay. So basically, this is inheritance with multiple parent classes. Okay. So how we can do that? It is quite simple. First of all, let's create a class. Let's do flyer. Okay. And here def init double underscore, here self, and let's do name, and self dot name equals to name. All right. Now what we can do here, we can add basically a method here, def fly, that will take self, and then it will not take anything more. Okay. And here we can do return f string. Let's do self dot name flies or flying high in the sky. Okay. All right. Now let's define another class, which is swimmer. Okay. So class swimmer. All right. Here we will have the same thing as before. So let's do that. Okay. And here, instead of fly method, we will have the swim method. Okay. All right. Def swim, that will take self, and here what we'll do, we will return the f string. Okay. And let's do self dot name is swimming good in the pond. Okay. All right. So now we are having two classes here, right? So one is flyer and another is swimmer. So what flies and swims? A duck. Okay. So let's create a class of duck. Class duck. And here it can basically extend or inherit from the flyer as well. So flyer. All right. And then what we can do here, we can just add a pass currently right now. And here we are not using the multiple inheritance yet. Okay. So, but here what we can do something like, so let's do Captain Cook is a duck. Okay. So duck. And here we have to pass a name. So Captain Cook. Okay. All right. So let me just capitalize this one and this one. All right. So we are having this duck here. Okay. The duck object. And here, if I just print right now, Captain Cook dot, as you can see, we are having the name and the fly method. Why is that? Because we are extending from the flyer class. Okay. So we can do fly. Okay. Here, and now run the program. We are getting Captain Cook flying high in the sky. Okay. Awesome. So this is quite good. Okay. All right. Now how we can use the multiple inheritance here. So duck will fly, also duck can swim as well, right? So what we will do, we will just add a comma here, and then we will pass another class here. So swimmer. Okay. All right. So in that way, what is happening currently right now, we are having this flyer class, we are having the swimmer class, and our child class, which is duck, is extending or inheriting from the flyer class as well as from the swimmer class. Okay. So now if I just print right now, Captain Cook dot, as you can see, we are having the swim as well. So swim. Okay. All right. Now, if I just run the program, we are getting Captain Cook is flying high in the sky. Captain Cook is swimming good in the pond. Okay, awesome. So as you can see, we are here inheriting from two different classes. Okay, and in case if you are wondering, yes, we can add our own init method as well, and here we can call the both of the like the super classes here. So what we can do something like this. So def double underscore init double underscore self, and then we will have the name, and here we can call the super dot double underscore init, and we can pass the name here. Okay, we don't have to pass the self. All right, so now if I run the program, we are getting Captain Cook is flying high in the sky, Captain Cook is swimming good in the pond. Okay, awesome. So here we are basically using the multiple inheritance here. Okay, now there is something to point out here. So first of all, what I'll do, I'll go here inside of this flyer class and create a method def greet, and here it will take the self, return, and then do the if string hello from, okay, so hello from flyer and self dot name. Okay, all right, so hello from flyer. Okay, all right, now I will just copy this one and paste the same method here. Okay, have to indent that properly, and here it will be not flyer, it will be swimmer. Okay, all right, so we are having two different greet methods. Okay, inside of the flyer we are having hello from flyer self.name, and here we are having hello from swimmer self.name. So now what if I call this greet method right now? So if I just do print Captain Cook dot greet, so what do you think, which method will run? Okay, which print statement we will get? Will it be the flyer or the swimmer one? Okay, because both of them has the same method, which is greet, right? And here we are extending from flyer and swimmer. So let's run the program right now. As you can see, we are getting hello from flyer Captain Cook. Okay, so as you can see, we are getting the flyer message here. Why is that? So we will discuss about this particular behavior of like multiple inheritance in the next video, when we will be discussing about the method resolution order, or the in short MRO. But currently right now, just to keep in check, because we are passing flyer at first. So in case if I just cut it out from here and paste it down here. Okay, now if I run the program, so as you can see, we are getting hello from swimmer Captain Cook. Okay, so this order matters. Okay, all right, so what I'll do, I'll just cut it out from here and paste it down here. Okay, all right, but in the next video we will discuss about the method resolution order, and there it will be a little bit more clear why exactly it is happening. Okay, awesome. So here in this video we have learned about the multiple inheritance in Python. Okay, hey, welcome back. In this video we will discuss about method resolution order, or MRO, in Python. Okay, so we have seen a little bit of the example when we have been talking about the multiple inheritance with the duck example in the last video. In case if you haven't seen that, please go watch that first. Okay, so when multiple parent classes share a method with the same name, Python needs a way to decide which one to execute. Okay, Python uses the C3 linearization algorithm to build the method resolution order, or MRO. So how we can check for MRO? We have this special method, which is the dunder MRO method. Then we have this MRO function here, and then we can check it with the built-in help function. Okay, all right, so now let's see that in action. First of all, let's declare a class which is A, okay, and it will have the greet method, def greet. All right, okay, it should have the self, and then print hello from A, okay. All right, then to save some time, we can just copy paste this one. We will have the class of B as well, so B and hello from B, okay. Then we will have the class of C as well, hello from C, and then we will have the class of D, okay, and it will have the pass. All right, or let's define the greet method here as well. So def greet self print, let's do hello from D, okay. All right, this is quite simple, okay. And now if I just go here inside of the D class and add the constructor, okay. All right, self and then super dot init, okay. Currently right now we do not have the super because we are not extending it from somewhere currently right now, so I will just comment out it for a moment. Now, so if I just create an object called my obj equals to D, okay, and then my object dot, let's do greet, okay. So what do you think will happen? Okay, so if I just run the program, we are getting hello from D. Quite simple. Now let's do some inheritance here, okay. First of all, we will have the class A, which is a self-containing class. It will not inherit from any other classes, okay. Now the class B, it will inherit from A. The class C, it will inherit from A as well, okay. And the class D, it will inherit from B and C, okay. So in case if you want a diagram, this is the diagram which I have developed for you. So this is our class A, okay. So all of the things from class A is getting inherited by the class B and the class C, and the class D is inheriting from the class B and the class C, okay. In case if this is a little bit more simple to understand what exactly we have done. So this is the diagram. So here, now, here we are having this greet method in each and every class, okay. Now let's see what exactly we are getting. So when we are doing something like my object.greet, what should happen? Run the program, we are getting hello from D, okay, fine. Now if I just do something like this, so we are calling the constructor, and here we are doing the super method, and then we are calling the constructor of the parent. So what we are expecting here, okay. So run the program. As you can see, we are getting hello from D here as well. All right, now what I'll do, I'll comment out this one, okay. Now what do you think will happen? Which print statement will be printing here with the greet function, okay. This is a valid code, right? Because B and C, all of them has the greet function here, the greet method associated with them. So what we will get here, so let's find out. Run the program, we are getting hello from B, okay. So this is how Python is determining what to set here, okay. So we are getting hello from B here. Why is that? Once again, the order matters because we are passing B here first. So in case if I just do something like this, Now if I run the program, we are getting hello from C. Okay, all right. So let's revert it back. All right. So now let's go to the B class. Okay, here. And now let's comment out this method. Now it will complain like, hey, there is nothing. So I will just add pass. Okay. Now what do you think will happen? Which print statement will be printing? Run the program right now. We are getting hello from C because B has no greet method right now. All right. Now let's comment out this one as well. Okay. Let's do pass here. So now we are having this one, right? So if I just run the program, we are getting hello from A. Okay. So this is how Python internally checks for all of the method which has the same name and uses the method resolution order. So now let's see how we can see the method resolution order. We are having 3 different ways to do so. First of all, this one, then this one, and then this one. All right, so what I'll do, I'll just get rid of this one, uncomment this one, get rid of this one, uncomment this one. All right, and I will uncomment this one as well. So all right, now let's see how we can check for the MRO for the classes. Okay, many of the times you will import some of the classes from external libraries and there you do not have access to the source code, right? In that case, you can check for the MRO as well. So how you can do that? Let's find out. First of all, we are having these ones. So double underscore MRO double underscore. Then we have this one, the MRO method or the function, and then we are having the help one, which is really interesting. So first of all, let's do something like this. So print, and we have to pass the particular class here. Okay, so the class D, so D, then dot double underscore MRO double underscore. Okay, now if I run the program, we are getting this one. Okay, so this is the MRO for the class D. So what it does basically, it will check for the greet function currently right now in the class D at first, then the class B, then the class C, then the class A, and then the inbuilt object. Okay, which currently I believe do not have a greet function associated with that. All right, so this is how we can check for the MRO. All right, then we have another one. So print D dot MRO function here. Okay, run the program. So here, as you can see, we are having 2 different print statements here. First print statement is giving us this tuple, which is for the double underscore MRO double underscore. And the second print statement is for this one, the MRO method, which is giving us a list. Okay, and the contents are quite similar. Like, hey, it will check for the D, then B, then C, then A, and so on. Okay, this is good. Now what I'll do, I'll just do something like this, and let's do print help, and let's pass the D class here. Okay, run the program. As you can see, this is a little bit more readable, right? So we are having this class, which is D, which is extending from B and C. And here we are having the method resolution order, which is D, then B, then C, and then class A. Okay, and then the built-in objects. Okay, all right. And then we are having these ones, and so on and so forth. Okay. So here, in that way, by using the help function, we can check for the method resolution order quite easily. All right. So I will just do Q to quit out. Okay. Awesome. So this is the method resolution order in Python. So in this video, we have discussed what exactly is the method resolution order and how we can check the method resolution order for a class in Python. Hey, welcome back. In this video, we will discuss about encapsulation in Python object-oriented programming. Okay. So when we are defining our class in Python, sometimes what we do not want that any other user can access some sort of an attribute of that class or a method of that class outside of the class. And we don't want that any other person can modify the attribute or the method from outside of the class. Okay, in that case we use encapsulation in Python. Okay, so encapsulation is about protecting data inside a class. Okay, it means keeping data, that is properties and methods, together in a class while controlling how the data can be accessed from outside the class. Okay, so this prevents accidental changes to your data and hides the internal details of how your class works. Okay, and I will get back to this comment later, why we want to use encapsulation. Okay, so let's see the encapsulation in action. Okay, all right. Now let's define a class person. Okay, and here we will have the constructor. All right, it will take the self and then it will take the name and then age. Okay, and here what we can do something like this: self dot name equals to name, self dot age equals to age. All right, and here what we can do something like this. So now what we can do, we can instantiate the object person1 equals to person, name can be John, and then age can be 24. Okay, simple enough. Now what we can do something like print person1 dot name, and then we can do person1 dot age. All right, makes sense, right? Now if I run the program, we are getting John and 24, which is expected. Now for example, we want to make the age private. So how we can do that in Python? We can do that by using a special syntax while basically instantiating this attribute here. So we have to add double underscore here. Okay, now if I want something like this, double underscore age here, now if I run the program, we are getting an error. Okay, the person object has no attribute called double underscore age. Okay, so in that way we can make an attribute private inside of a class by using double underscores. All right, so this is the private property. Okay, so private properties cannot be accessed directly from outside the class. Now the question is how we can access the age value from this person class. Okay, so it is quite simple. We have to create a function which is a getter function. So while using the encapsulation, we will see the terms getter and setter quite a lot. So here we have to add a getter method inside of the person class so that we can get the age of the person. All right, so now let's define get age. It will take the self and simply it will return self dot double underscore age. Simple enough. So now if we want to get the age, what we have to do? We have to do something like this: get age. Okay, we have to call it. This is a method. All right, so now we are getting 24. Okay, so as you can see, quite simple, right? So we are just defining a getter method here, basically a getter function to get the age. Okay, now how we can modify the age? Okay, how we can set the age basically. So to set the age, we can add a setter function or a setter method here. Okay, quite simple. So here what we'll do, I can do something like this. Def set underscore age self. Okay, and here it should get the age, right? The new age. Okay, here we can do something like if we can add a check. New age is greater than 0. Okay, then self dot double underscore age equals to new age. Okay, else we can raise a value error. Okay, and do something like age cannot be less than 0. Okay, all right. So we are having this particular check here before setting our age. Okay, and this is a setter function. All right, so now what we can do something like this, print, or let's do something like this. Before the get age, what we can do something like this. So person1 dot set age, and here we can pass our new age can be 30. All right, now if I call this function here, so as you can see here, we are defining the set age function, which is a setter function, and here we are setting our new age inside of our person class. Okay, all right, now run the program. We are getting 30. Now John is 30 years old. Okay, simple enough. So in that way, we can use the getter and the setter functions to get the private properties and to set or update the private properties. Okay, awesome. So now why we want to use the encapsulation? Okay, so let's find out. So why to use encapsulation? Encapsulation provides several benefits. Okay, something like data protection, prevents accidental modification of the data. Okay, then the validation, you can validate data before setting it, which we did, right? We are validating here the data. Okay, all right. Then flexibility, internal implementation can change without affecting the external code. And then control, you have full control over how data is accessed and modified. Okay, so this is basically the encapsulation in action. So now let's see what exactly is the protected properties. So we have discussed about the private properties, something like this. Now we have the protected properties as well. Okay, and this is basically a convention. So Python also has a convention for protected properties using a single underscore. So what exactly do I mean? So the person can have a salary. Okay, and here we can do something like self dot underscore, only one underscore here, salary equals to salary. Okay, quite simple. And now while making this one, so what I can do something like this. So 50,000. Okay, so this is our protected property. Now the thing is, the protected properties can be accessed by outside code as well. So what exactly do I mean? I can do something like print and do person1 dot underscore salary. Okay, this is totally fine. Run the program, we are getting 50,000 here. So as you can see, we are not getting an error, just like the private properties, right? While we cannot access the double underscore age here, we are getting an error. But here for the protected properties, which starts with only a single underscore, do not give an error. Okay, so what exactly does that mean? So the single underscore is just a convention. It tells other programmers that property is intended to be internal use. Okay, so this is basically to say to other programmers like, hey, you can access that and you can update the property, that is totally fine, but please do not do that. Okay, so in Python does not enforce any sort of restrictions while using the protected properties. Okay, so I will add a comment here, private property, and this will be protected property. All right, I hope that makes sense. Also, just like the private properties, we can have private methods as well. Okay, so let's see that in action. Okay, so here what we can do, we are having this one, right? So here we can add a simple validation here. So def, let's do double underscore validate age. Okay, it will take the self and it will take the age here. All right, and here what we can do something like this. So if I just do copy this one here, okay, all right, we have to do something like this, age, and that has to be age as well. So as you can see, this is our private method. Okay, so now what I'll do something like this. If this is the case, return true, and if that is not the case, return false. Okay, all right, simple enough. Now what we can do something like this, or we can add the validation error as well. Okay, so Control C, let's do something like this. Okay, let's raise the validation error. All right, now what we can do something like this. So get rid of this one, get rid of this one here. So we are having the age equals to new age basically. So here what we can do, we can check if. Okay, so we can do something like self dot double underscore validate age. Okay, and we have to pass the new age. If that is true, then only do this one. Okay, otherwise don't do anything. So as you can see, this is how we can abstract many parts of the code which should not be accessible outside of the code, right? So now if I run the program, this is good. Now if I do something like this, so if I do something like -2, okay, run the program, we are getting an error, right? Age cannot be less than 0. Okay, I hope that makes sense. So in that way, we can create our private methods inside of the class as well. Okay, I will just go ahead and do 30. All right, so this is the private methods. And now as you can see how our code is getting shaped, it is getting shaped quite well, right? We can abstract out many of the parts of the code from the end user, so they are not worried about the implementation. Okay, all right. So here, one last thing which I want to point out in this video is name mangling. So if I just do something like this, so if I will just do something like this, okay, so here if I print the person 1, okay, so what we are expecting, we will get an object. Simple enough. Now we have the special property which is the double underscore dict double underscore. If I do that, as you can see, if I just run the program, we are getting name John, and here surprisingly we are getting age, which is basically modified to this one. So the class name and then double underscore age, which is 24. Okay, and then the salary, which is this one. So this is called name mangling. Okay, so name mangling is how Python implements private properties and methods. Okay, so when you use the double underscores, Python automatically renames it internally by adding the class name, like the underscore class name in front of it. Okay, so here theoretically or practically here, if I just do something like print person 1 dot underscore person double underscore age, if I do that, run the program, we are getting 24. Okay, so in that way we can access the private properties as well. But do I recommend it? Absolutely not. You should not be doing anything like this. Okay, while you can access private properties by using the mangled name, it is not recommended. Okay, it defeats the purpose of encapsulation altogether. Okay, you should not be doing something like this. All right, so in this video we have learned like most of the things about the encapsulation here. Okay, so all right, in this video we have learned about encapsulation in Python. Hey, welcome back. In this video we will discuss about the property decorator in Python, which closely relates to encapsulation in Python. Okay, so let's get started. First of all, as you can see, we are having this person class, which we have defined in the last video. Here we are having the private property of age, okay, double underscore age. And here we are having the getter for the age here. And we are having the setter for the age here. And we are having this validate age private method here inside of the class. Okay, quite simple. And now, as you can see, if we want to get the age, what we have to do? We have to do something like this. Print person1 dot get age, and we have to call the function, run the program. As you can see, we are getting 24. All right, because here it is 24. And then if we want to set the age of the person, what we have to do? We have to do something like this. So let's do person1 dot set age. Here we have to pass our new age, which is something like, let's do 30. Once again, run the program. Now the age is 30. This is good. But what if we have a simple syntax for getting and setting the age, something like this? So if I just get rid of this one or comment out this one, what if we can do something like this? person1 dot age to get the age, and to set the age we can do something like this, 30. And to get the age we can do something like this. So person1 dot age. That will be a little bit more nicer, right? This is totally fine, but this syntax is a little bit more nicer. So how we can do that? All right, so I will get rid of this one or comment out this one for the time being. Now what I'll do, I'll go here inside of this one, okay, inside of the class. And what I'll do, I will just comment out this one, the setter and the getter here. Okay, so we will have the validate age here, which is good. Okay, now we can do the same things by using the property decorator. So we can do def age self, and it will return self dot double underscore age. Okay, this is good. Now we have to decorate this method by @property. Okay, now this age will act as a property of the object, okay, which is being created. All right, so now if I just go here and do something like this, person1 dot age, okay, run the program, we are getting 24. Okay, all right, so this is the getter. Okay, so this is how we can use the property @property decorator to create a getter. Now let's create a setter. So how we can do that? We can do that by using @ and then we have to add the property name, which is currently age. All right, then dot setter. Okay, and this is our decorator. This is the custom decorator here. Now we have to do define the function, which is age once again, and here it will get the self and new age. Okay, and here inside of this function we have to first validate, right? So if self dot double underscore validate age of new age. Okay, if that is the case, okay, this is our validate method here, validate age method. And now what we'll do, we will do something like this: self dot double underscore age equals to new age. Okay, all right. So we are doing mostly the same thing as here. Okay, but now what will happen? By using this decorator, we can do something like this as well. If I just do that, run the program, we are getting currently 30. Okay, so as you can see, our defined functions are acting as a property of the object instance. Okay, this person object instance. So as you can see, by using the add property decorator, we can basically create the getters and setters for our encapsulated properties in our Python classes. Okay, all right. So in this video, we have learned about the add property decorator in Python. Hey, welcome back. In this video, we will discuss about polymorphism in Python object-oriented programming. So what exactly polymorphism means? The word polymorphism means many forms, okay? And in programming, it refers to methods, functions, or operators with the same name that can be executed on many objects or classes, okay? So polymorphism can be multiple types, okay? We have the function polymorphism and we have the class polymorphism. So we have seen the example of the function polymorphism before, okay? An example of Python function that can be used on different objects is the len function, right? So as you might have remembered, we have something like this, okay? So if I just add a string, something like ABC, I can do something like add a list 1, 2, 3, or even I can add a dictionary as well. So Z equals to something like A is B, something like this. For all of these data types, the len function works, right? We can add a string inside of the len function. We can add a list inside of the len function. We can add a tuple inside of the len function. We can add a dictionary inside of the len function. So this is an example for the function polymorphism. So I will not be discussing about the len function because we have discussed about the len function in a previous video in details, okay? In case if you want to learn more about the len function and how it works internally, you can check that previous video, okay? All right. Now the thing which we want to see here is the class polymorphism. So polymorphism is often used in class methods where we can have multiple classes with the same method name, okay? So what exactly does that mean? So let's define a class here, class vehicle, okay? And this class will have the constructor in it. It will take the self, it will take the brand, and it will take the model, okay? And it will do self dot brand equals to brand, and then self dot model equals to model, okay? And here it will have a method associated with that. So move, okay? It will take the self, all right, and then it will print something like moving, all right? Quite simple, okay? Now we can have a class car which will inherit from the vehicle, all right? And here I can just do pass, okay? All right. Then we can have a class of boat which will also inherit from vehicle. All right. And here we will redefine or override the move method. Move self, and then we can print sailing. All right. Simple enough. Now we can have another one, class plane, that will also inherit from vehicle. Okay, and it will also have the move method. Okay, and it will print flying. Simple enough, right? So we are defining the class vehicle, which has the brand and the model, and it has the default move method. Then we have the car class, which is extending or inheriting from the vehicle class, but it does not have any sort of move method. Then we have the boat class, which is also inheriting from the vehicle. It has the move method. Then once again, we have the plane class, which is inheriting from the vehicle class, and it has the move method here as well. Okay, so let's see that in action. So let's do car equals to car. All right, have to add the brand, Ford, Mustang. All right, then we will have the boat equals to boat, and here it can be, I do not know, the boat brand, something like that, boat brand, and the boat model. I do not know about boats. Okay, so please do not judge me here. All right, then plane equals to plane, that will have the brand, which is Boeing, and then it has the model, which is 747. All right, this is good, right? Okay, now I want to print all of the brand names and the models and so on. So what I can do, I can add a for loop here. Okay, so for X or V for vehicle, basically in, I will open up the brackets here, the parenthesis, car, boat, and then plane. Okay, for each of the vehicle, what I want to print the v dot brand, I want to print v dot model, and then I don't want to print anything. I want to call v dot move. Okay, all right, simple enough. So here, if I now run the program, as you can see, we are getting all of this. So Ford Mustang, which is moving, then boat brand, boat model, which is sailing, and then we have the Boeing 747, which is flying. Okay, so as you can see, this is a really nice example of polymorphism in classes. Okay, so here, as you can see, with the help of polymorphism, we are defining the move method basically inside of the children classes, inside of the boat and inside of the plane, right? We are defining our custom move method. Okay, so in that way, we can extend the functionality which our vehicle class is providing to us. Okay, in case we do not extend that, in case of the car, as you can see, we are not doing anything. So we are just fallbacking to the move method which the vehicle class has. Okay, so this is the example of polymorphism in Python object-oriented programming. Okay, I hope that makes sense. So what exactly polymorphism means? Polymorphism means many forms. As you can see, our vehicle class is taking many forms, in form of the car, in form of the boat, and in form of the plane as well. Okay, and there we can define our own custom method, or we can override the existing method which is inside of the base class basically, and do something which we want to do inside of that particular class. Okay, awesome. So we have learned about polymorphism in Python object-oriented programming. Hey, welcome back. In this video, we will discuss about the static method decorator in Python. In Python, the @static method is a decorator that is used to define a method inside a class that does not access or modify the class state or instance state. Okay, so we have seen the class methods and the instance method. The instance method has the self parameter and the class method has the CLS parameter. So when our function which we are defining does not need or modify the self or the CLS parameters, it becomes a static function. Okay, and we use the static method decorator to convert that particular function static. Okay, so it behaves exactly like a regular function but lives within the class's namespace for logical grouping. Okay, so let's see that in action. First of all, let's add a class math operations. Okay, so this is our class. Let's add a simple class attribute description. Okay, not this one. All right, a simple math utility. Okay, all right. Now we can add a method here which can be add. So what we can do something like this. So def add, and here by default we have to pass the self as the first parameter. Then we can pass two numbers, so num1 and then num2. All right, and then what we can do something like this: return num1 plus num2. Okay, simple enough. So now if I just do something like this, so something like sum underscore result, it can be something like this. Okay, so what we can do something like math operations. Okay, and then some result dot add, we can pass two numbers 5 and let's do 4, or let's do 7. Okay, and we have to print it out. Okay, all right, this is good. Run the program. We are getting 12. Okay, so this is all good. So as you can see inside of this particular function, the add function, the first parameter is the self parameter. But what exactly we are returning? We are returning num1 plus num2. We are not using the self parameter at all, right? So if that is the case, then what we can do, we can use the static method decorator. Okay, so here what we can do, I can just comment out this one currently right now, and here we have to decorate this function with @static method. Okay, now we don't need the self parameter at all. Okay, here. All right, so now how we can access this static method? So if I just do something like this, this works. Okay, so if I run the program, we are getting 12. But this is not the proper way to access the static method. Instead, what we have to do, we have to get rid of this one. And here, what we can do something like this: math operations, and then on the class dot, we can call the add function, and here we can pass two different numbers here. So num1 and num2. Num1 5, num2 let's do 10. All right, run the program right now. We are not getting anything because we are not printing anything. So print some result. Okay, all right, run the program. We are getting 15. Okay, as you can see, this is how the static method decorator works. Okay, and you might be thinking, if that is the case, we are not using the self parameter, then what we can do, we can just copy this function or cut it out and paste it down here or up here. Okay, so if I just indent that properly, okay, that is totally valid. But once again, the add function here is grouped with the math operations class, right? So it should be inside of the math operation class. It should not be outside of the class here. So if we want to add a function which does not basically modify the class state or the instance state, then we can use the static method decorator here. As you can see, by using the static method decorator, we are making this add function static. So that means we do not have to pass the self parameter inside of the add function anymore. Okay, so now let's see one other example of the static method here. Okay, all right, so def is underscore even. By default, it will get the self here, and then it will get the number. Okay, and here we can return num modulus of 2 equals to, or double equals to in that matter, 0. Okay, so if num modulus 2 is 0, that means the number is even. Okay, all right. Now, as you can see, once again, we are not using the self parameter at all. So what we can do, we can do @static method, and we can get rid of the self parameter here. Okay, all right. So now, so let's do is even result equals to math operations dot is even, and we can pass something like 5. Okay, and here we can do something like this: print is even result. All right. Okay, so now if I run the program, we are getting false. Okay, simple enough. So, all right, in this video, we have learned about the static method decorator in Python and how we can use the static method decorator to make our functions inside of the class static. Okay, awesome.